And before the talk starts, I want to give a few pointers. The Q&A session will be conducted via Slido, so you're encouraged to post your questions there. You can also upvote a question that you find interesting. Please also mute all the devices that you have during the session, and you're encouraged to post about the talk on Twitter. Please use the hashtags PyCon.de and PyData Berlin. Yeah. And with that.
Yeah, great. Thank you very much for this introduction. Yeah, my name is Daryna Dementieva, and I'm a postdoc and TM, and I'm very, very glad to see you all in my talk. So yeah, it's an attempt to keep up with all the rapid development in NLP. So yeah, a couple of words about myself. So I am a researcher in NLP, and I finished my PhD also in this topic. So I'm doing this already for like 6-7 years altogether, and my research is very much connected how I can apply all these very powerful models. You can see they are really developing almost every year, every half a year, every month, to many social important topics like how we can fight misinformation, how we can fight toxic speech, how we can fight hate speech. And yes, I think also it aligns with this year's thoughts and ideas of this year conference. So we also heard a lot already about AI for social good, NLP for social good. It really can cover a lot of topics, not only some textual things, but also maybe healthcare, agriculture, and actually so this year also I'm organizing a workshop at YMNLP, which will be in Miami, and where we also will have a discussion about how we can, again, think about how we can apply and do some positive social impact with all these big models. Yeah, and I also want to say many thanks to all my colleagues, because this talk is very based on work with my colleagues, PhD students, master students, and my supervisors, and we did a lot of experiments about also different domains, about formality, about toxicity, what I will talk about today, and we then publish quite nice papers. You can also find them online and also read if you want to, cover many more details. Yeah, so, again, so this talk is about trying to keep up with all modern NLP. And actually, when I was preparing this talk, I was really very ambitious, and I was like, yeah, so I will will try to keep up, and I will try to monitor all new models. And when I was going from Munich to Berlin, it was on Sunday, and I was really just preparing some slides and thinking, yeah, it was, quite come 2 months, and I really feel that indeed I covered all the most popular models, and then what happened? If you also read in Twitter and read in different NLP use, Meta introduced their new model, Llama 3. It was April 18, and just yesterday, so actually it was today's morning for me, Microsoft published also their new model, Phi 3. So what can I say? I will try my best. And also with this talk, we will already not cover these super modern models because they're just several hours old. But yeah, at least we will have a glance of how we can use and if indeed these models are indeed so capable or maybe not so capable. Yeah, so basically what we want to find out with this talk. First of all, if we want to have a classifier, we'll look about very typical NLP task. If you have ever had courses about NLP, or maybe, I don't know, heard some courses online. So really we have some data set and we have labels, and we just really want to input some samples and then have this label. And first to set up, if we want to have such a classifier for English language, which is usually the most resourceful language right now. So yeah, if we have some new appearances of data or models, it's usually for English language. But then, of course, English is not the only language in our world, and maybe we want indeed to have other classifiers for other languages, and then maybe we don't have actually so much data for this language, and so what we can do with this, and if we can indeed have successful classifier, or maybe not have, but yeah, hopefully we can do this. And on the other hand, yes, like finally, maybe if we have data for many languages, English, and somehow also for other languages, so if we can combine it all together and have indeed multilingual model for all these many languages, and also how we can do this. Yeah, and just to have all these examples, I will be talking about 3 main tasks. It's very typical NLP task, which you can see also, again, maybe in some courses and just online, some popular data sets. So the first one, how we can detect toxicity or hate speech. Yeah, so toxicity, it will be about if we have a sentence with some obscene lexicon or some rude intention, so we consider this text as toxic, and otherwise it will be just non-toxic. So hateful is about if we want to insult someone and based on their race, background, or something else, and all other sentences are counted as non-hateful. Grammatic classification is about if we have maybe some sentences that have some short words or maybe some emojis and do not follow all the punctuation, we count this text as informal, and on the other hand, if we have fully grammatically correct sentences, the sentences are formal. And also third task, I will have some examples about this as well. So it's not like binary classification task, it's actually a relation about two sentences. It's called natural language inference. So if you have one sentence called actually premise and another is hypothesis, and we want to classify a relation between these two sentences. It can be contradiction, entailment, or neutral. So this, very typical NLP task. And yes, if you will see some maybe root sentences on the slides, it's not to offend you, it's just for illustration. Another value that maybe I wanted to also come up with this conference. So also we talk about a lot about open source at PyData Berlin, and very huge resource for NLP right now in terms of open source in Hugging Face. So how many people have heard about Hugging Face before? Oh yeah, cool. Very nice. So we have very dedicated audience, and I believe, maybe you have heard of it, but maybe how many people indeed using it every day in their job or so a little bit less already, just for a couple of people who maybe don't know, Hugging Face is a very big platform, and it hosts a lot of model data sets, and actually all even these big players in IT industry are also trying to publish all the models in open source and Hugging Face. And nice thing is that not only you can publish something there or download something from someone, you can also, for example, if you don't have GPUs or you don't have compute to host these models, you can also call APIs from Hugging Face for some parts for free, for some parts for some, maybe not so big costs, and they will also inference your models for you. Just also to mention, so this talk is not sponsored by Hugging Face, but could have been, but I'm just very excited about this platform, and really as for NLP researcher, we take and we try to also publish everything at this platform. So let's start with our first task, if the target language in English, and we indeed can have some data. So indeed, there are so many data sets in English language. For example, for toxicity detection, we have a Jigsaw data set that covers several millions of samples, actually, of different granularities, and there are also some other data sets of hate speech. For example, for hate speech, very famous one is Hate Explain. For formality classification, there is a paper called Dear Sir Madam, introduced you to the idea of data set. They have also monolingual and multilingual version. We will talk about this later. And for NLI, there are also actually several versions of NLI datasets for English. One of the most popular one is SNLI dataset. I think it was from Stanford Group. And so it's really, these are quite popular datasets, and you can also see them in many papers using as benchmarks. And today is April 2024, and what we can do if we want to do some classifier, we actually today can either prompt some large language model and maybe expect that it will give us some correct answer. On the other hand, we still actually can fine-tune some mass language model additionally for our downstream task. Let's discuss indeed what should we do. Just to mention, indeed, like this prompting of LLMs, it doesn't require any fine-tuning. So indeed, you can just host LLM somewhere. It can be your machine, or it can be your server, or it can be someone else. On the other hand, actually, indeed, you also even can fine-tune LLM, but we assume that we are not OpenAI, and we are more humble people, and so we will just try to prompt these LLMs. Indeed, if we want to fine-tune something, so usually maybe we will go with mass language models. How actually then indeed to choose LLM? I also will advertise one of the pages from Hugging Face. It's called LLM Benchmark, and usually all LLMs that are published at Hugging Face. They're also evaluated on this benchmark, so then we can understand indeed what the model is good about, what this model is not good about. And I really recommend to visit this website, and you can also filter these models based on their pre-trained data, on I think even languages, on the sizes, which is, size is important in this case, because really there can be huge models of several hundreds of billions of parameters, or maybe we can come with, deal with several millions just maybe for this task. So really, I recommend this page at least to understand the picture of what is going on. And so maybe we have chosen some more or less decent models of more or less adequate size for our humble resources. And I believe you have already heard the name of Llama, and you already have heard the name of Mistral, and these are open source LLMs. On the other hand, we have this closed source LLMs from OpenAI, and also there is another company called Anthropic. Yes, but one of the popular models, I believe, ChatGPT and GPT-4. But actually, I also believe that maybe not all of people heard about Fluenty5. So how many people have heard about Fluenty5? Actually, so not all of you, and it's actually not indeed like large LLM. It's also was instruction fine-tuned still language model, and if you can see on the bottom, I also mentioned the amount of parameters. So Fluenty5, it's from 60 million to, indeed, they have like XXL model, I think this is how it's called, is 3 billion parameters. So Llama, Mistral, so this already scale from, sorry, it's a typo, actually 7 billion to 70 billion, and even some models even more. And ChatGPT is an ensemble of several billion parameters models, really like a huge ensemble. But why Fluenty5 is still interesting for us? Because actually this is a model with which all this power of big large language models became so nice. And I really recommend to check out the paper. So it's called Scaling Instruction Fine-Tuned Language Models. And indeed, it was possibility how these models can be indeed scaled. And the secret was that they also took a lot of data sets, these typical NLP data sets from different benchmarks, and they constructed this both text classification and text generation task in text generation task. So like even classification task, it was constructed in the generation task. So you can prompt your task, you can prompt also your sample, and you will indeed get the label. It will be generated as a text. And that's why they, and like the thing is that for classification, if we again want to have this text classification task, it's basically for what this model was designed, that it was instructionally fine-tuned to do text classification. And that's why we will talk about this model, and I will show you the results. So how we can design a prompt, actually. And there are also many recipes how you can do this. We came up within our chair and within our experiments with such a way that we indeed trying to tell the models we want to classify text, and trying to explain which domain we are working specifically right now. Also, you can even maybe insert some definitions if you have some, for example, domain definitions or definitions of your task from linguists, so you can also somehow insert it into your prompt. And also we're trying to restrict that, please reply with only one word, because then the model will generate a huge amount of text. And also try, even names, labels, so either this word or this word or this word. Then you can have several examples. It can be like few shot prompting, 1, 2, 3, as many as possible. So also actually there is a scene to find this balance between not to give too few examples, but not to give too many examples, so the model will not be over-tuned for a task, let's say. But try to showcase what you're expecting, and then you have text, your text, and then you're expecting the label. But anyway, of course, the model can hallucinate, and indeed, sometimes it can answer with one word, but it also can be not a case. And I'm always recommending, so for example, you can at least find the first keywords that appeared in the answer, because maybe it can be a sentence or a text. Or on the other hand, if you have open source models that you're using on your machine and you can control the outputs, you can also check out their output from the last layer, because anyways, the generation is a prediction of the next token, and you can check probabilities, and also to find the most probable, again, presence of some keyword in this list of candidates for the next token. Yeah, I hope it's clear. So talking about transformers, so actually we have a very big transformer zoo, and this is a reminder of most also popular and very often used models in papers. BERT model, which was also like built the foundation of all this research. And then we have RoBERTa model that was just bigger version of BERT and outperforming many tasks. We have GPT-2 model, was actually a decoder part of transformer, and we have T5 and BART models. It was also both encoder and decoder. But yeah, for classification, actually, we, in the majority of cases, use encoder-based models because we want to encode text, and maybe then, yes, maybe this is a slide to talk about, we encode the text into some dimensional space, and then we even should not fine-tune the whole model for our downstream task. So we can only use the classification token and feed it into fully connection layer, and also have, for example, yes of max layer afterwards, and use this for classification, and only fine-tune actually this full connection layer and yes of max layer. So we want to use yes fully connection layer, and you also can design it in any how big, how many hidden states you want to have there. So usually, actually, we don't use very big fully connection layers. It's maybe indeed can be just one hidden state, but you can add more. Maybe you can experiment. It's always a happy parameter. But yeah, once again, like because these models were designed to encode the text, and also they had special tokens. So usually you have in transformers tokenizers this token separation and also token classification. And the idea is that within this token classification, we indeed trying to encode the whole meaning of the text. So you can only work with this specific token. Yeah, so let's talk about some numbers. The first table is about toxicity and hate speech classification. So my colleagues, they had actually very big research. So I have, yes, the name of their paper, so also you're very welcome to check out it. And they indeed compared all these models like GPT-3, Da Vinci, so it also was GPT-style model from OpenAI, and then Fluent-T5 on a hate speech classification task. And if we look at the numbers, so, and also, yes, they also tried different strategies, but if we look at the numbers and what we actually expect, we expect the GPT 3.5 or GPT-4 models, they were heavily fine-tuned, so with this human feedback, not to behave toxically, not to behave hatefully, and actually detect this hate speech. Yes, like that was actually the idea, and this model we were expecting that they should be super amazing in detecting hate speech, but this is not the case. So if you indeed insert some hateful speech or some hateful speech data set, and you want to indeed fairly evaluate this model, so it's actually not so amazingly good. Yes, so it's good enough, but it's not amazingly good. And if you look at the numbers, so for GPT 3.5, it's 0.61, and for Fluent-T5, it's 0.66. It's even a little bit better, or we can argue so maybe data sets doesn't showcase the whole hate speech in the world, but anyway, Fluent-T5 model without any fine-tuning is a model which is way less than ChatGPT behaves on the level with the model. Also have in comparison classifiers that we also, and I personally fine-tuned for this was a task of even this data set specifically. So for example, the second row is a BERT model, BERT actually cased model fine-tuned on hate explained data set, and it performs already way better than these prompted LLMs. We also prompted Llama model and Mistral model, and they also showed maybe not the best results, so actually Mistral performed the best within these all LLMs. And actually, yes, it's actually kind of good model, and I will also have another information about it. And indeed, it's really super decent model. For toxicity, we also fine-tuned RoBERTa model, so it's a bigger version of BERT, and it also was pretty nice, and it was not even large model, so it's still very decent classifiers. For formality, it's like another showcase with another task, and we firstly even prompted Llama as well. So Mistral was not like so popular at that point, but we prompted Llama firstly, and we saw, so actually the results were not even so good, and we didn't even publish it in the paper, but we tried different classifiers, even starting with these old-fashioned classifiers with punctuations, bag of words, fast text, and you can see that specifically for this task of formality, even these simple classifiers is performed pretty good. Then we fine-tuned different transformer-based models, and indeed, of course, the bigger the model, it's the better, and indeed, these models still are pretty decent. And Mistral was in the end, I would say, middle results. But so for this task, it was the answer that it's actually nicer to fine-tune again some nice language model additionally for the task than prompt LLMs. Yeah, and as this main takeaways from this part that, instruction fine-tuned LLMs, it can be really even more efficient and effective, efficient because they occupy less memory and they also need less time for inference. And, but even if we maybe spend some compute to fine-tune language model for our downstream task, it will be even better and more also effective. Yeah, but let's go to another part. If the target language is not actually English, and also the usual case for non-English languages is we also don't have enough data. And so for me it was a case that we actually have Ukrainian language here because I speak Ukrainian and it was my mother tongue, and we also assume that we have a source language English. So what can we do then for this? And we actually have 4 ways, and if I would name the main slide of my presentations, it will be the main slide of my presentation. Let's have a closer look for this. What first of all we can do? So the first step can called back translation. So we have text in Ukrainian, and which is then translated to English because we also have right now very powerful models for translation from any language to English. And then we actually already use fine-tuned classifier, for example, for English language, I just prompted already English text and expecting the label. On the other hand, we still maybe can try to use to prompt LLMs, Llama, Mistral, or any other model. What we also can do, we actually can translate English training data into our target language. And again, the power already of translation systems, they really allow us to do this. And then we can fine-tune maybe LLM or just LLM for this downstream task, and then already have prompts in Ukrainian. On the other hand, so it's a little bit more efficient method how we can fine-tune is adapters. So we can use some multilingual language model for encoding our text, and then we have adapter in English language, and then we have also another adapter. Adapters, so also they are, like, let's imagine just not so big fully connection layers with some hidden states, and you can also stack them all together. And we freeze these first layers of encoding the language and adapter for the language, and then we fine-tune this last layer for our specific task. And then the magic can happen that we just switch the language adapter, so we have adapter in English, and then we substitute it with adapter in Ukrainian, for example, and then we can also prompt in Ukrainian, and we can expect the label. So I also recommend, so we have Hugging Face, we also have actually the platform called Adapter Hub, where you can find all these fine-tuned languages, so they also trying to cover as much language as they can, but already you can find there a lot of information. Another question is how we can choose translation system, and we tried also three ways to do this, and the first ones are open source and another one's commercial. So DeepL is, I think, it's even a German-based company, and so what were the results? Opus NLP Helsinki, it's one of the open source model, and it was actually pretty good in specifically translating toxicity. No language learned behind is a big model from Meta, and it was really also quite powerful for open source model, and it was very good in translating some neutral sentences. And the thing is that indeed already it was like a new generation of LLMs, and it was heavily over-tuned to be very polite. So that's why it was impossible to gain any hateful or toxic speech from this model. And DeepL actually was very good in every task, but just we stick to this open source choice, and we didn't use this model, but we actually recommended. So it was really pretty nice model to do. And we had several thousands and hundreds of thousands of data sets, so translated from the ones that I showed you in the beginning from English data sets. And also we tried to imitate some semi-natural test sets, maybe just trying to find some keywords with toxic sentences, just to imitate if we just not use translation data, but some natural Ukrainian data to test our models. Some also couple of words about how we can design the prompts. Actually, it's absolutely the same structure. The main thing that anyway, all instructions, so all these key parts of prompt were still in English. So it was not possible to write everything in Ukrainian, but because the models were anyway heavily tuned for English language. So anyway, these tasks, definitions, everything was in English. And then, of course, we can have examples in our target language and then our input in target language. So the results. Between LLMs, their king and the queen was Mistral AI, and each one in every task. Llama 2 was not good at all. Also, we tried actually experimenting translating Ukrainian data to English, and then again prompting Fluent 5, but anyway, didn't work so good. So Mistral was really nice. And yeah, maybe we can skip this scene, just to mention that if you want to find the model for your language that is somewhere included, it's very nice to go to Hugging Face, select your language, and check that it was indeed participating in pre-trained data of the model. Yeah, so the final table with results, so what we did for Ukrainian language, comparing all these different approaches, what we can actually observe. So yeah, indeed, Mistral was pretty good, but for toxicity, fine-tuning some language model was the best choice, and it was the best behavior on semi-natural test set. For formality, yeah, Mistral actually was quite good on both translated and semi-natural data, and yeah, adaptive training was actually also pretty nice. And for NLI, it was actually kind of challenging task. So on one hand, if you look at the data, even in English language, so sentences are not super difficult. But if you want to emulate this data in other language, more morphologically rich language, it was actually kind of switching the domain. Yeah. Also, we did several experiments with formality classification tasks. So also there were several languages, and we're trying to combine if we fine-tune on this language and then test on this language, and etc., etc. So it was just a showcase that when you have many languages, it's also kind of heavily computing experiments trying to find the combination of language that will help you to transfer knowledge to other language. And it's still a very big room for research in our field. Yeah, but then anyway, main takeaways. So we indeed can use this approach of translating data, and it can be a really good bridge for a abuzz classifier for language. At least in our experiments for Ukrainian, Mistral shows the best performance on a still language. However, yeah, fine-tuning language model for classification is still a strong solution. And also, we did this showcase of transferring knowledge for English to Ukrainian, but of course, if we look on the family languages and the relation between languages, English is not the closest language to Ukrainian, so maybe if you're thinking about other language, it maybe makes sense to have a look, for example, again at Hugging Face, just looking for some languages that are similar to your language more than English, and yeah, maybe trying to do these manipulations with, in together in pair with another language. And yeah, maybe also another table to how you can choose your fighter, depending on how many steps of inference you can have, and also on which APIs, external APIs you want to depend. Because of course, back translation was good baseline, but then you have to have this 3 inference steps, and you're heavily dependent on translation system every time. With training data translation, you can translate the whole data set in once, but then you need to fine-tune, for example, yeah. With LLMs, you still also have just one inference. You can do this, but anyway, you can be dependent on API. With adaptive training, it was one of the most efficient ways how you can actually fine-tune the model, but there were anyway some flaws in classifier. But yeah, if you're lucky and you have more data, maybe you can just indeed fine-tune the language model and just host on your machine. Yeah. Maybe just a couple of slides. So indeed, if we have English language, another language, and more data, so if we can fine-tune some multilingual model, and we tried this for multilingual city classification, and right now actually we have a shared task going on, so if you want to participate in the task of transferring style from toxic into non-toxic, you're very welcomed. But the recipe here was that we tried to have a balanced data set for training data and for test set across all languages, so yeah, per class and per language. And we have right now a multilingual model for classification of toxicity for 9 languages. And if you look at the results, so it's more or less decent, more or less equal across all languages. Yes, of course, for some languages it was the original quality of the data not so good, but anyway, it's possible to do this. The same I can say for formality. So also we tried to fine-tune models for all 4 languages, and we also tried different setups. But if we want to fine-tune, for example, some multilingual language model like BERT or RoBERTa, so it's indeed possible, and it can be really fairly enough for all languages. Yeah, so cross-lingual and multilingual classification is possible, and especially right now, especially with so many models and possibilities. LLMs, you need really to cross-check if you want to do something rather than English. You need to cross-check how much data or even your language was present in pre-training data. It's really extremely important, and how it's balanced or non-balanced in comparison to English data. Also, you should not forget that actually it's all right to use all special classifiers, even Vega-wars, even linear regressions, even LSTMs, and even just fine-tuning transformer models is also still valid. Yeah, so I want to just leave you with a couple of slides with links so you can check my Hugging Face. And yeah, I was starting with a point about open source. So even in my chair where I worked before and continue to work, I encourage all our research to publish online at Hugging Face. All the models, the data sets, you can find everything with all these repositories. Yeah, so take pictures and QR codes. And the last QR code I want to share is that we're also trying to create a Discord server actually for all NLP developers, researchers within Germany and even maybe within Europe. So we are also very welcoming to join you, and we can discuss there all this crazy news about all these crazy models, and maybe some meetups, and maybe helping with some issues or finding master theses or whatever you need. So yeah, please join, and we will be really happy to see you. Yeah, so thank you very much. Thank you very much for coming, and I hope it was useful, and we will develop very fair and multilingual NLP models.